Hello.
Hey, how is it going?
Good. How are you?
Yeah, doing good. So this is for system design mentorship practice.
Right.
Gotcha. Can you provide a little background of yourself and where you are in the interview process right now, and what are your expectations from this interview?
Sure. I'm a software engineer in the data side. So you can call me data engineer. Um, and I have had over 4 years of experience. Um, and I'm right now working at uh, uh, a Lyft. Um, and I have few interviews coming up next week for on-site. Uh, and Over last year, I did take a few interviews, and then system design is one of my weakest points. Um, and so I wanted to make sure that if I'm following the structure well, or I want to see where I'm missing things. That's why I choose to do a mentorship interview. Um, do you want, like, the expectation from this call is to make sure, like, to understand from the other side, like, what is expected out of system design, and what are the red flags, what are the things not to do, and how to structure it and how to go about it. Obviously, I followed the structure given by grokking the system design interview, and I think uh, that that I failed because of following the structure, because and I thought to myself, like, uh, going with intuition is better, not blindly following the predefined structure. Um, yeah, so this is what I have in my mind at this point of time.
Okay, so if I understand correctly, did you give system design interviews last year and it didn't go well?
Right. Yeah. I think, yeah, it's because coding wise, I'm pretty sure I'm okay with that. I think system design is where probably I might have offers signed because of that.
Gotcha. And for data engineers, like what is the bar for system design interviews? Is it same as
Uh,
interviewing?
I think I have an interview with Instacart, and they have a dedicated round for system design. Like, mostly people don't put system design for data engineers, but this is in the data infra, it seems. So the bar is same as software engineers, and I have software engineering background as well. So the bar is pretty much same as software engineers.
Okay, sounds good. Sounds good. Okay. Uh, so you're not actually interviewing right now, but you want to get, in the right direction and get the feedback.
Right. Yeah.
Okay, sounds good. So do you want to like solve a problem and then as you solve it, do you want me to guide through and what the expectations are?
Yeah. Maybe that sounds good.
Okay, sounds good. How about uh, designing file hosting service similar to Dropbox or Google Drive?
Okay. I don't think I have done that before, so probably it's probably a good idea, I guess.
Also, have you used
Uh, have I used what?
this platform before?
Interviewing.io?
Yeah,
Not for system design.
gotcha. Yeah, so there is
Yeah.
just a draw tab. That is the only difference with coding rounds. At the bottom left of the screen, where you can draw high level or detail level design diagram.
Right. Okay.
Yeah, and also let's target to complete in 40 to usually 45 minutes. That would
Okay.
be a good time for majority of the companies.
Okay. So, so the idea is to build a file hosting service like Dropbox or G Drive, right? Um, so the first thing I would like to start is go with the use cases expected. Obviously, this is for interview sake, and we can't, like, we have limited time. So, uh, so to understand like functional requirements of what is expected out of this. So to begin, right, this is Google Drive. So uh, for extracting use cases, should is this something I have to come up with, or should I ask the interviewer to give use cases for me, like to see what he is interested in?
Yeah. So the usually the expectation from the system design interview, at least in my sense, it is basically you'll be given an ambiguous problem, and what I want to see is how does the candidate deal with an ambiguity. Let's say once you join a
Hmm.
particular company, I mean you're already working at Lyft. I mean that itself is
Hmm.
like a really good company, and you might already know about
Hmm.
this. So basically,
Hmm.
you'll be given like a design or a mini design in your project, and most of the time you wouldn't know where to start with, and how do
Right.
you go about figuring out those requirements, and what are the design goals, what are the latency requirements, what are the other services that you have to interact with or make changes to, and what are the milestones and stuff, right? That is the goal. Like how do you deal with the ambiguity, and how do you uh,
Okay.
provide structure to the problem which you are trying to solve, where you don't have any context of it. So most of the
Okay.
time, I would recommend the candidates, to come up with the use cases and ask clarifying questions.
Okay.
Uh, yeah, and the interviewer should be able to correct and or add on to the requirements that you provide.
Okay. Sounds good. Yeah. Okay. Then in that case, Google Drive. Uh, the primary workflow or the use cases is to upload a file, and that's the. So I'm just gonna write a few features here. Um, Upload a file to Drive. When we talk about a file, then probably we need to discuss uh, further on what kind of files we have to upload, we have to support, right? It could be text files or media files, or like depending on that. Uh, so uh, I'll touch base with this uh, once I'm done with the rest of the use cases. The first thing is uploading a file to Drive. Um, and once we upload, the obvious uh, next step is to download, or like to fetch the file which we uploaded to the Drive. So download a file from the Drive. Um, what else? What else? What else are the use cases apart from uploading and downloading files? Um,
Ability to share the files with some set of users.
okay, sharing files with others. Um, and then there is also a feature called syncing, right? Like you can sync a particular drive or folder. So do you think that's something we can handle, or is that
Yeah,
out of
yeah.
scope?
No, that is in scope. Yeah, that's definitely a great feature, like syncing
Okay.
across multiple clients and also syncing a folder on a given client.
Okay. Uh, all right. So is this a good number of use cases to tackle, or
Yeah, I think yeah, these sounds good.
okay? When it like I mentioned I would iterate on this. So do we care about any file types, or does it like are we particular about any particular file type, or
Yeah,
should it support anything?
yeah, it should support anything.
Okay, so that's a generic files. Okay. This is functional requirements. The next part is non-functional requirements. So here we would like to talk about scale, right? So when we talk about scale, we need to know how many users are we expecting, right? Um, like total number of users, um, and uh, daily active users. So do we have any numbers for this?
Yeah. How about I mean, you can give it a shot and we can iterate
Okay.
on it.
Okay. So uh, probably I think 500 million uh, total users,
Sounds good.
and daily active users probably we can say um, like almost 10% of uh, 10% of the total active users. So 50 million.
Mhm.
Uh, so this is a lot of users. So this has to be a highly available system, and uh, so in talking about in terms of nine, I think four nines is a like pretty good system to design. Obviously, we can go for five nines as well. So is this a good figure, or should it has to be five?
Yeah, I'm fine with 4 nines.
Okay. And then, so one more thing is this system going to be write heavy or read heavy, right? Um, so we would probably it's going to be read heavy, I believe. Is that true?
I mean, it need not be. It can be. I mean, depends on the use cases, I guess. But I would say the read and write are pretty much balanced here.
Okay,
Uh,
one is to one.
yeah, 1:1 because some customers just want to write file and use as a backup mechanism, and some, like to share files and so yeah.
Okay. Uh, so again now, this might be a dumb question, but like in Google Drive, we can actually view it in browser, right? So uh, do you think that could be considered as a use case,
Uh,
or is it part of downloading a file?
yeah, I'm not too concerned about it. To be frank, I mean, I'm mainly concerned
Okay.
about the design, like how do you design the
Okay.
service to be available and available and also durable.
Okay. Uh, okay. So in terms of obviously in terms of latency, um, we expect like we expect the downloading part to be quicker. Um, and since the read and write ratio is similar, so we obviously expect this to be of very low latency. And one more important thing is consistency, and basically the data durability. Uh, since like since we are when we upload something, like we assume once it's successful, we assume that it's gonna stay consistent and durable over that. So I believe like these two, um, durability is one of the most important thing. Uh, coming to consistency, let's say if a file is uh, being uh, do we care about strong consistency or eventual consistency, as the question is?
I think in this case, eventual consistency is fine, especially if you are syncing across multiple clients, right?
Okay, yeah.
Yeah.
uh, okay. uh, I think i have I have got a good idea of in terms of like how big the system is, and I think I have captured most of the highly available, or like the non functional requirements here. So the next thing is like, do you want me to do the estimates for you know the bandwidth estimates or the storage estimate?
Yeah, yeah, that would be good.
Okay, so estimates. Uh, so obviously we have 500 million users. So uh, so per day basis, uh, how much? So if we talk about uh, per day user data, like how much does a user upload per day. So probably 500 MB. That's is this Does this sound good for you? Average data uploaded by user per day.
Yeah, yeah, that sounds good.
Okay. So if that's per user, then obviously we have 10 million active users. So 10 million into 500 uh, megabytes. So that's easily 5K, and so 5,000 terabytes, which means 5 petabytes per day. I think this makes sense. So we are talking about 5 petabytes of data storage per day. Um, what else? I have not defined any APIs yet. So should we like? Do you want me to ideally? Do you want me to go ahead with the high level design, or should I get into the APIs and try to get the network bandwidth required for upload or download or whatever the other APIs which might be interested?
When you say APIs, like the APIs used by the clients to upload the data.
Right.
Yeah, yeah. For this one, I'm not super interested in the API design.
Okay.
Yeah.
So we can go ahead with. I mean, the main thing is since this is a drive, right? Like this, the main thing is how much data we are uploading. So this is per day. So this, I think this might be enough. I can do estimates for you know for 5 years or for 1 year as well. Uh, do you think that is required at this point of time?
It's okay. We can visit that later. Yeah, we
Okay.
can move to the design.
Okay. All right. So let me see. I have not used this feature. Okay. Looks like simple. So let's assume we have a client here. Um, this is not that pretty to use the tool.
Yeah, it's
Uh,
not. Yeah, I mean, it don't have to be neat.
okay. Yeah, I'm not able to. Can I undo?
It,
I'm not able to delete it.
yeah, so there is like the circle, like the third icon from the bottom. Oh, sorry, the third icon from the top. If you
This
expand
one.
it, the circle one, that is the eraser.
This
No,
one.
no, not the one. There is the second one, which is the eraser.
This one.
Yeah.
Okay.
Oh,
And this
oh,
one.
oh. Not the circle one. The second, the third from the top, and if you expand it, the second one, which looks like an eraser.
This one. Okay. I see. Okay. Uh, just gonna drop probably. Oh,
So you might have to reduce the size of the.
yeah. So here we have a client, right? We have multiple clients, and these clients can be using a web browser or mobile device. Uh, and here there is at this point of time there is no need to create a persistent connection. So I'm gonna uh, treat this connection as a need basis. So like a regular HTTP should be good. Um, so this the client connects to load balancer. Once we connect to the load balancer, uh, we can have microservices, one for upload and one for download. Uh, let's say this, let's call this write service or upload or write service. I'm just gonna design the monolithic kind of service, and then I'll try to uh, uh, make it highly available later. So when a client connects to load balancer, and from here we would load balancer calls a particular API service implemented using probably a RESTful service. And then basically this one will upload it to a database. Uh, okay, talking about specifics here. So based on the file sizes, if the file size, um, so obviously here we would when a client asks to download a particular file, or when he wants to share a particular file when he shares this particular file with others, they want to download it or they want to view it, and we can't obviously uh, hit database every time a user wants to read a particular file. So we can maintain a cache in between write and the database. Um, I'm going to just write it like this. Um, and this cache can be Redis or Memcache, and this can have probably the most. We can use algorithms such as LIFO to make sure that this cache stays consistent. So whenever user writes a particular file, um, I realize I haven't discussed the schema for the database yet. But whenever a user wants to write a particular file, he writes first to the database. He checks if he writes to the database, and then later uh, the process also updates that particular file in the cache. So and then it sends acknowledgement to the client. Uh, the files in the client has been successfully stored in the database. When someone user wants to each file will have a URL, right? URI. So when someone else wants to download that file, so instead of hitting the database, we can just fetch it from the cache and return it. Since this is just read only. The bottlenecks here is obviously we need to have this service as stateless. So we need to have multiple instances of it so that we can use uh, some hashing algorithms such as consistent hashing to map particular users' files uh, to one of the services, one of the write services. Um, and I forgot to mention. So there will be a read service as well, which basically interacts with the cache, and if there is no data, then only it goes and hits the database, and then it updates the cache, and then it returns the data back. And here we are just using a request response protocol HTTP, since this is a need-based kind of system. And then one more bottleneck is the database, right? The choice of database. For the choice of database, we will have each user will have a user ID, and he will have a particular file. So instead of storing the file directly here, because database, like if you're using a relational database, it's not meant for it. But here, since we are just talking about a user uploading a file, and then uh, it can be updated by many people. So there is that problem. Um, like Google Drive, you can multiple users can work on a single document. So uh, for that reason, uh, if if we were to use um, if you were to use a NoSQL database, like just a key value store, I think we might have problems with that because of consistency. I believe um, multiple users updating or connecting to the same multiple users writing to the same file. So that might be a separate task to handle, I guess. Uh, I think probably I should have checked with you if that is something we need to support, right? Multiple user, multiple document editing. Do you think that that fits in the requirements, or is that not valid?
Gotcha. So, are you suggesting to use NoSQL database to store the files?
Uh, so I was thinking initially that would work probably better when we do not have a problem of multiple users updating a particular document.
Gotcha.
Since it doesn't give the asset properties or like the yeah I think yeah probably this is since we will not store um, it depends on how we store the file, right? Like obviously media files we will not store directly in the database. uh, so talking about schema here again, user ID, let's say this is files, right? So each file will have a file ID, um, who uploaded it, and what's the type of it. And here, let's say URL, right? If it's media, then it's better to store in some object storage such as S3 and have that link over here. Uh, since media files is not something you would edit, right? You would just upload a new file if you want. You won't go and edit a new existing file. So so that makes sense here. But if the file types is something like text file, like doc or something, uh, for those, I was thinking, would it make sense to store the contents of the text files as a blob, or yeah, as a in the database itself, or should it be stored in a separate media like we used for uh, like we use for audio or videos? And I do not have much knowledge on this, but I think it doesn't make sense to store a text file over some object storage. Uh, and probably it might make sense to for that to be part of the database column itself, uh, so that any updates um, can be delegated to the database instead of us handling it directly.
Yeah, the problem with the NoSQL data stores, many of the NoSQL data stores is most of them doesn't have good size limits on the value field. Like let's say, I think most of the data stores support like in KBs. So let's say if you want to store a 1 MB text file, basically you don't have capability to store that in one row in NoSQL data stores.
I see. Okay, there is a serious constraint on the value then, right?
Yeah, there are serious constraints on the value size. So in the considering
Okay.
that, I think it makes sense to store in the on the object data store, which you're planning to
Okay.
use to store media and media information.
Okay. Um, then in that case, if that were the case, then uh, so obviously I cannot think of any analytics being done to see or like any kind of uh, entity relationship model here uh, to prefer a relational database over NoSQL database here. If you're just storing the media contents directly in the object storage, and would it make sense for us to use a NoSQL database which offers uh, sharding capabilities and replication and failover inbuilt failover scenarios? Since we are talking about 5 petabytes of data per day, uh,
Right.
and
So before going that, there I had a question with respect to. So you talked about having multiple write servers and having a consistent hash string. So are you
mhm.
planning to have consistent hashing for the write servers?
uh, let me think through that. Uh, so write is when user is trying to upload a particular file, uh, and consistent hashing is a way to decide to which box to send this particular request to. Um, uh, yeah, I think yeah. I mean, like by using consistent hashing, uh, we would consistently put the same user uh, to the same box as long as the box is, stays alive. So the advantage of that is we can cache user related data in that box. Uh, and I'm just thinking if there is any scope for having those things over there. Obviously, I would have uh, general services like user authentication, authorization, and stuff uh, in the load balancer itself. So I mean I
Okay, so
don't
you
see a Mhm.
yeah, yeah, go ahead, go ahead.
Yeah, I was like uh, consistent hashing is probably the reason I chose this. I think probably it might work with any sort of hashing here since at least I'm not able to think of any reason why we should uh, delegate why we should tie up a particular user to one box constantly. So and obviously consistent hashing will make sure will help will distribute the load uh, evenly when we have when we need to increase or decrease the write services node like but in this cluster like any nodes adding or deleting any nodes. So probably consistent hashing is a good choice, I believe, and that's why I chose that.
Gotcha. So what you're suggesting was you're planning to have cache on the host itself, on the write servers itself, and by using the consistent hashing, you figure out the right partition where the user's data reside, I guess, uh, and talk to that host. Is that what you're intending to do?
I think that part I missed since I was uh, I got lost in deciding the database, right? So the next step is like once we have the request forwarded to write service, then write service actually writes to the database, and obviously this has to be sharded because we are talking about a large volume of data on a day-to-day basis.
Mm-hmm.
Um, and to shard, we can use user ID uh, in a hashing algorithm to decide to which shard to map to. So all the files created by this particular user get stored in a particular shard. Um, so I think, yeah, like you covered it, but yeah, that's probably that's one thing I missed. Um, and yes.
Gotcha. So exactly, there are database shards, and basically these there are write servers, and these write servers, what they do is they talk to a particular shard, uh, they talk to a particular database shard where the data resides, and they cache the data on the host.
Right. Yep.
Is that a representation? Okay. Is that okay? So, and how are you planning to handle, like, let's say if a write server goes down for a given user, how are you planning to handle that case?
If a write server goes down for a particular user, uh, then
Because,
like mhm.
yeah, go ahead.
Yeah, like I mean, if we were caching, if we are using local cache in that particular node, then we would lose that obviously because we just lost that particular server, that particular node. Uh, and then what happens? Oh, if a write server gets uh, uh, if we lose a write server, then we would use a different. Do you mean in the middle of before acknowledging the request? Uh, in the middle of writing a particular request?
No, let's say if the request comes to the load balancer, right? Now the load balancer has to figure out what what is the what is the right server it has to talk to, because from what
Hmm.
you mentioned, these right servers are based on a consistent hash string. So let's say the load balancer has the logic to figure out the correct right server, and
Hmm.
let's say it forwards the request, but it found that the server is down.
Hmm. Uh,
How are you planning to handle that case?
right. Like if a particular node is down, then uh, I believe that's the responsibility of the load balancer to forward that request to some other node which is alive, right?
Right. Are you saying there are multiple write servers per shard?
Uh, so uh, write servers is independent of. There is no tie between write servers and shards. Um, write servers works in
Okay.
like when write server gets a request, uh, it uses hashing algorithm based on the user ID to figure out to which shard the file should be stored.
Gotcha, gotcha. So what you're saying is the write servers are stateless. Basically, the load
Yeah,
balancer can forward the request to any write server, and
right.
that write server will have the logic to decide which database shard that data actually resides.
Where to store that particular file information.
Gotcha, gotcha. Okay, now I think I understand it well. Okay, sounds
Okay.
good.
Uh, I'm still not clear on the database part, and uh, this is one more thing I would like to be improve my knowledge on. So, like we need to track the users who the files created by a particular user, right? So, if I were to have a table like files, and each file we generate, we would each file would have a unique ID, which would be UUID, it seems. And then we would tie which user generated it, and then the type of the file. Probably this could be, and then since we decided on using an object storage for everything, so what's the URL of this? And probably some other time, like created at when was it created and the last modified at, and all those fields. So if we are using these fields, then probably it makes sense to use, like, since there is a proper structure we can see, uh, so we can probably use SQL databases such as NoSQL, um, and the volume of, like, since we are talking about how much, I was just thinking, did we discuss the volume of the writes we are handling? I think we just spoke about uh, the data, not the kind number of entries, right? Like if a particular user uploads 10 files per day, then we can think how much uh, the volume of this particular database, how would it go, right? Um, so since we saw a proper structure to this table, we can use a relational database. And since we're not storing any um, media here directly, so it's a simple storage. And since this explodes as we have more users, and I have known theoretically, like, relational database. One of the uh, drawbacks of using relational database is it doesn't scale well, and it needs to be it doesn't come out of the box, since it offers things like transactions and data durability and consistency. Like, if we shard, then it's going to be hard because of the extra network IO that it has to deal with every transaction query. So, like, I'm not able to think of, like, let's this is again a question, right? Like, should we use NoSQL here, or should we use a SQL and implement sharding based on user ID?
Right. So I feel like uh, yeah, you can use uh, yeah, NoSQL or MySQL for storing the metadata, and I think you can achieve whatever functionality you're looking for using both the data stores. Uh, Personally, I feel like relational database might be better for this use case because there is a lot of structured data, right? Like there is files.
Mhm.
You need to store information about files. You need to store users, and then for each user, what are the files that are associated, and for each file, you
Yep.
need to store a lot of metadata, when data and stuff, and you need to store what are the devices that given
Right.
files have been synced to, and you need to store permissions associated for a given file, like who can access these files or not, and also some information about the folders that have been synced and stuff. I guess either can be used, either NoSQL or my SQL, but I feel like
Hmm.
SQL is the it feels a better use case for this problem at least. And yeah, people say it is very hard to scale SQL databases, but I don't completely agree with that. There are like
Okay.
many companies which have extensively used SQL and developed technologies on top of it to scale better and stuff. And
Okay.
MySQL itself comes with a inbuilt replication and sharding story. So yeah, uh, that's my take on it.
So if I hear you right, we can use MySQL database, and we can use out of the box replications, and we can also do sharding, right? Is that true?
Yeah.
Okay. Um, so if we want to talk about sharding, what would be the best strategy to shard here? Should we go with user ID, or should we go with the region from which the user is using is from, or should it be from the device?
Yeah, I feel like user ID should be a good key to shard on, or to consistent hash on, or to shard the database on. That feels like a that feels like more let's say that, yeah, that fits the use case better compared to other fields.
Okay. Um, yeah, I think it's probably like 45 minutes already, and I missed a lot of points, like uh, sharing. Uh, Sharing is probably just one more, uh, adding a column or something related to database. It seems in terms of the implementation, it seems pretty simple, at least for me. Um,
Actually, if we have, yeah, let's spend like 2 to 3 minutes on the client side, because we didn't talk about the client component altogether. So let's say
okay.
if a user comes and up like a 1 GB or 2 GB file, like he drops a folder into the Dropbox client on his machine, and it has to be synced. Like how does
hmm
that work? Let's say if it has a file 2 GB,
Okay, it's a
what
very
does
big file
what is
basically. Okay,
big file?
5
Yeah.
GB of data. Yeah, I think yeah, this is a good point. Um, I think we need to, you know, we need to divide this. We need to break this particular file into multiple smaller sections, and like the way HDFS stores files, right? We need to break uh, into smaller parts and uh, allocate these parts. Uh, so that's the high level thing I'm considering. So like to be 100% specific, to go with the details, I hits the load balancer with that much data. We are still carrying that much data over here, and we would forward that request. Uh, we would forward that request to write, and in the write, it will divide this data into smaller chunks or smaller blocks. And no, it doesn't make sense, because if you upload this 5 GB of data directly in an object storage such as S3, it does all these things by itself. Uh, so like we are carrying that 5 GB data till the till the write service. Um, I'm not sure if uh, if we have to do anything at our side uh, to break this large file before storing it in an object storage such as S3. So yeah, like
Uh,
I'm all ears. I'm not sure how to deal with this.
yeah. So my expectation was, let's say if there is a 5 GB file that is being uploaded on the client side. So what I'm expecting is there can be like a component on the client. You can call it a chunker or a file divider or something, which
Okay.
basically divides that file or fixed size bytes, and basically uploads each byte and stores chunk that information, like the index information for each chunk, and then basically it constructs that file if whenever the user accesses that file. So I think, yeah, I think it makes sense to have that component on the client side for multiple reasons. One being, you don't have to wait to upload that much data, and let's say if there is a intermittent connectivity issue, then you have to start uploading everything from scratch. So dividing
Right.
into multiple help you deal with multiple things. You can do parallel processing, parallelly upload all the data, and you can parallelly divide the data into chunks, and yeah, and it's easier to store on the database side as well. I mean, you can use S3 and other stuff to store large files, I guess MongoDB and stuff, but I feel like having that component on the client side makes sense.
So we would divide this large file on the client side and have the client side update or upload each block parallelly, uh, and so that is like how do we how are we ensuring that all these blocks belongs to a particular file? How is that information? Where is that information stored in that case? How is that propagated, right? Like how does it flow through the system?
Right, right. So yeah, whenever you make a request, upload request for a chunk, then you need to provide the file information and the user information and the device information that it's coming from. Like if there is like, let's say, file a.txt, right, which is like 1 gig. So and
Hmm.
user u1 is user user abcd is uploading, then you provide abcd a.txt, also the chunk name and the chunk size, something like that. Are you
So
asking
like
where does the data get? To come to know that about it.
so user A uploads 5 GB of data, right? And
Mm,
client basically divides this into probably 500 MB blocks, right? So
mhm.
what I was asking is, let's say this is a dot something, right? Like MP3 or something. So my question was like, how do we associate this 500 MB blocks uh, to this particular big file? Way how like do we store that, and if we do, then how are we storing that? That was my question. In the back end, like how do we when user asks for this file again, we need to fetch all these things and send it back to the client so that the client can construct it rather than us. So right,
Yeah, your question is how to back. Okay. So basically,
how
whenever
do
you
we
upload
store it?
the information, yeah, so yeah, you need to store a bunch of metadata associated with these chunks. Like you can
Hmm.
store sequence numbers, right? I mean, you can have an
Okay,
auto increment for each of the chunk, or you can have sequence number, which are not
right,
strictly increasing, or you can have
right.
like a manifest file. For each file, you can have a manifest file which actually stores uh, the information of each chunk in kind of a uh, in an orderly fashion. That way, the first element in the manifest file basically points to the first chunk, and the second element points to the information for the second chunk, and so on.
Okay.
Not sure yet.
Uh, yeah, I think probably I can
I can
probably figure out. Oh, good.
basically manifest file, right? And let's say each chunk size is like 500 KB, right? So this will be like chunk one and 500 KB and the location of the chunk. Similarly, chunk two 500 KB or whatever, it can be 400 KB as well, but let's say 500 KB, and then location of the chunk, and so on. And this need not be strictly increasing, right?
What does location mean here?
The location of the chunk in the
Public
we are
storage.
having two data stores. One is the metadata data store, which actually stores information about the users, permissions, files, and another
Hmm.
is actually the object store.
Right. Okay.
This could be the location to the object store,
Okay. And we also need uh,
or it could be like this
to.
as well. Like 1 to
Okay.
10 chunks are present in location, and
Okay.
11 to 20 chunks are present in location, something like this.
Okay. Sounds good. Uh, yeah. So, like, what do you think? Where do you think? Uh, Obviously, I don't go as structured as I go with the coding. Uh, uh, for, like, for lack of practice, or I'm not sure, but like, what do you think? What's your feedback for me?
Yeah, let's move to the feedback since we have 5 minutes left. And yeah, I think overall the way the interview went, I'm inclined to hire. I think you do understand distributor system concepts and basically designing scalable and available microservices. Yeah, coming back to the improvement section, I guess we lost. I felt like there was some back and forth on the write servers and on the database servers and their sharding. Initially, I thought you mentioned about write servers being on a consistent hash string. Maybe I misunderstood it or something. So
Hmm.
my understanding initially was load balancers, and these load balancers has the logic to figure out what is the right server associated with that user, or a user and a file combination, and it will basically route the request to that set of hosts where the data is
Hmm.
present, like locally, and if needed, it can fetch that information from the database shard. I think there was some back
Hmm.
and forth. Either of the approaches work. I mean,
Hmm.
having like a pod architecture, like pod, there can be multiple pods, right? Each pod contains range of users' data, and all the right servers are in that pod are behind one load balancer for availability and redundancy. And a load
Hmm.
balancer can just figure out what the data resides, and it can write the request. It can route the request to that right pod, and then that pod figure out if the data is available locally, or if not, it goes to the right database shard. Either way, it works, I guess. But there was some back and forth on that, and yeah. Other than that, yeah, regarding the database design, uh, so I was expecting you to come with a metadata data store and an object data store out of the box, because those two fall into different buckets. One is like the metadata associated with your entire system, and the actual files, which can be really large. So
Hmm.
and since these are like optional files and stuff, it really needs, it fits to the description of a object data store. I think you came up with the object data store, but you initially mentioned only like really large files you're going to store on the object data store, whereas other
Right.
files you're planning to store on the metadata store. Right. So that was one minor feedback on the database design side, and you did talk about sharding, and you definitely understand how sharding works and how the consistent hashing works. Uh, on the and having multiple load balancers for redundancy and stuff. Yeah, and regarding, I was expecting to spend more time on the client component, which we couldn't. Actually, there are a bunch of interesting things to talk on the client component, especially how does the synchronization happen across multiple clients. Like, let's say the same user is uploading data from like 3 to 4 clients, or even uh, like, even though it's not uploading right away, but if it's uploading data at one client, how does that data go and sync on the other client when the user logins on the other client? I think there are like
Right.
good design challenges which can be talked about, especially uh, the architecture that you want to use for replicating the data to other devices, like using message queues,
Hmm.
uh, or submodel stuff. That would be interesting to talk about. I was thinking of spending some time on that, but we couldn't get time. And even on the client side, there could be bunch of other components. Like, there could be a component which will be listening for changes on the client. Like, whenever user drops in a folder, this component is responsible for
Right.
uh, listening to the changes and yeah, and doing the chunking component or whatever, and interacting with the synchronization service or the load balancer to write to the databases and stuff. I think yeah, one feedback I had was yeah, we could have covered a lot of stuff. I think the main core of the design especially the client component and the synchronization component. I would have been more happy if it would have been covered. So I would look out
Hmm.
for time management, and so if you are come out of the box about the metadata design and the data store design and how the write servers interact with the database design in one shot, then I guess we would have saved some time. So that is another feedback I had.
Okay. Uh, and like, what would you suggest? Ideally, the flow, right? Like, uh,
Yeah.
to
So I
make
think the
sure.
flow
Yeah.
you mentioned. Yeah. Sorry to interrupt. I think you mentioned like in some interviews you followed the flow before and it didn't work out well. I'm not sure what the reasons were for that, but I actually like the candidates to approach the problem in a structured approach, because that's how you write your design docs in right, like in your company or any other company. Basically start with requirements, and you start with non-requirements capacity, and you go into high level design and detail level design. I usually like that approach, but if someone doesn't like it, I don't know what could be the reason.
No, yeah, the problem with that is that is the same thing which happened now, right? Like, uh, obviously, like, you you were interested more with the client side, and if I just strictly follow this, like, probably I think maybe like this part is unnecessary, or maybe this part is unnecessary, like, because there is only so much time. uh, what I meant is, like, instead of strictly following, that means, like, after having established use cases and stuff, uh, uh, like, understanding what the interviewer wants to focus on, and then uh, delving into that, rather than uh, going through bandwidth estimates and database design and high level design, and then delving it. Probably, like, maybe I should be very fast, but that's one of the reasons I thought it didn't work out for me. Uh, just for probably being a little slow, it seems.
Yeah, I understand your question. So basically, if you follow the structured approach, you might not have enough time to cover the components that the interviewer would like to cover, or
Right.
I'm, or you might lose some time discussing some components. Uh, right. So I think the way for that is like for this interview, I think you initially took 15 minutes, I guess 15 to 16 minutes to finish the capacity until the capacity section. I think usually I would expect I would reduce that time to maybe 8 to 10 minutes. So in 8 to 10 minutes, you should be able to figure out requirements, non-requirements, and some part of the capacity estimations. And after 8 to 10 minutes, you should be able to ready to go to next section, which is relevant, like API design or whatever it may be, like high level design or a database design. So in this case, I specifically that's why I didn't want you to go with the API design or even write the
Hmm.
database design, because I was not interested in those. I was mainly interested on these components. Usually, I set the expectations to the candidate that hey, I'm interested in these components, but after your high level design, when you're going into detail, I was I was thinking of mentioning that, but as I said, we lost some time talking about the database design and also the
Right.
write servers. Yeah,
Yep.
otherwise I would have definitely asked you to move on to a different component for sure.
Okay.
So that is one thing you can set expectations if the interviewer is not setting the expectation. Hey, you can say that, hey, I'm going to start with the high level design. Let me know if you are interested in talking about one component in depth, or otherwise I'll go each component by component. You can set that expectations beforehand.
Hmm. Okay. And regarding database design, right? Like, uh, logically, should this come before delving into high level design? Uh, Probably that would have helped me decide if I had come up with this before. That would have helped me decide the choice of database and all. Uh, at least the way I think. Uh,
Come with what before?
so if I had come up with the database design, right? before going into high level design, uh, it would
Gotcha.
have
So when you
helped me.
design,
Yeah,
when you say database design, is it the schema are you talking about, or is it identifying the
the schema,
right database schema? Got it.
database
Actually,
design in
for
the
this,
sense, yeah,
Mhm. Go ahead.
defining entities and the schemas and all the metadata related information. Yeah, whatever we have written here.
Okay. Yeah, to be frank, I'm not that for this question at least I'm not that curious about how the schema looks like.
Okay,
Rather, I will be more interested in what kind of data store you want to use, like for storing the metadata and also for storing the objects, and why do you choose one or the other? I'm
okay,
mainly interested in that component, and how do you want to uh, ensure that the database meets the growth demands? Like, do you want to shard the database? If so, what kind of sharding uh, algorithm you want to use? And let's say if there are any hard partitions in the data store where you are receiving a lot of traffic and it is affecting the customers on that shard, like how are you going to identify those hard partitions? And so I'm
okay,
mainly interested on those things. Yeah.
okay. So you would be okay if a candidate doesn't describe the schema and just delve into the big data pictures, like uh, choice of database and how do we shard and scale and all those things, right?
Yeah, especially for this problem. I mean, for other
Okay,
problem it may vary. For
okay,
this problem, the reason being, as there are like other interesting components to talk about, right? As I mentioned,
right.
the client
Yeah, the client.
component,
Yeah,
this component. So, so I wouldn't have a candidate spend time on writing the schema and stuff. I mean, so yeah,
right.
for this problem at least I'm not in that.
Okay, yeah, that makes sense. Uh, one final question is, like, you mentioned about the, like, if multiple users are using the same document or editing the same document, and if you're storing that document in an object storage, how do we ensure the data durability, or how do we ensure the consistency between um, like all the users' data is shown to others and everything which the user has written is stored in the database?
Yeah, that's that's a tricky component to work with if multiple users are trying to uh, make changes to the same file, right? Then you need to
Right.
have some kind of locking mechanism, like you need to lock components of that file, or and you need to have like yeah, you need to have basically that locking strategy, and also some kind of conflict resolution. Most probably it should happen on the server side, I guess, because
Yeah.
it is coming from multiple clients. uh, yeah.
But, like, would you expect that to be part of the interview?
Actually, for this question, I'm not too much curious about the online editing aspect of it.
Okay.
I was just interested in like how does changes propagate from one client to other client, rather than like if the clients are trying to modify the same file, how does that work? I think that would be a better use case for like let's say for a Google Doc. Like let's say if multiple persons are editing same document, how does that work? I think that feels that problem better rather than this one.
Okay. And if you had that use case in mind, and if candidate doesn't while brainstorming he doesn't bring up that particular feature, so how, like, would you put that to the candidate to handle it, or is that, or would you just let it go?
You mean if the actual use case is like support online editing by multiple clients, and if the candidate was
Yeah,
not able to figure that out?
yeah, candidate, yeah, he, like I did, right? I didn't put that in the use cases, right? But that's a
No,
very mhm.
yeah, that's a common use case, but actually I was not too concerned about that use case. If I felt that that was applicable for our design, I would have definitely mentioned you, hey, you are missing this requirement.
Okay.
So for this problem, I felt like that was not like a really important use case to talk about. Maybe if we had time,
Okay.
we could have in that time, but that's definitely an extension to this question. But yeah, I didn't
Okay.
feel that that was an important use case. That's why I didn't correct you in the beginning.
Okay. And is that considered something is that considered a negative point if the candidate doesn't come up with good or standard use cases for a particular domain?
Uh, I wouldn't say so unless until if there is like a basic requirement, right? Like for this problem, let's say if the candidate doesn't come up with upload and download feature, and then that I would consider as something too obvious to miss. But offline editing or online editing, I wouldn't consider that as like too big of
Okay.
a problem if the candidate doesn't come up with those use cases.
Okay. Uh, yeah. And please feel free to. I'm not sure if this comes with. Does it come with verbal feedback as well, or sorry, written feedback as well? The
Yeah, it
mock
does.
sessions. Yeah,
Yeah, it does.
okay. Yeah, just feel free to put uh, anything I missed in terms of if this was a real interview, what would have how would have felt and what would have things missed. Obviously, you spoke a lot, but if you think you have missed something else, then please feel free to put it. This is one area which I'm working very hard on, so that would be very helpful.
Sure. So what I would do is I would try to take some open-end problems and try to think on your own and write it down how you're going to solve it,
Okay.
and I would actually read read about that problem. Like let's say if a company is solving that problem or through their blogs, or you can use standard
Mm-hmm.
interview platforms for questions and try to compare your answer and see uh, where can be the improvements. Before doing that, I would actually read about all the concepts associated with the distributions, like how does the CDNs work, how does the consistent hashing work, and
Mm-hmm.
different types of caches, and WebSockets, HTTP connection, TCP connections, and all basically cover all these concepts, and then
Mm-hmm.
try to solve a problem and write it down and look up the answer and see where can the improvements be.
Okay. Yeah, that sounds good.
Okay, then it was nice talking to you, and all the best with your interviews.
Yeah, thank you so much. Thank you so much for your time.
Yeah,
Have
bye.
a good night. Yeah. Bye.